Hydropower, the power generated by the flow of flowing water. It is one of the most suitable as well as efficient sources of energy. Hydropower is an efficient source of renewable energy and it has various potential applications for future power generation that cannot be underestimated. It is one of the most efficient, secure and reliable way generating power. The overall efficiency of the station water to wire operation is almost 90% efficiency. On the other hand, the startup cost of the hydropower plants is high, but it has low operation and low maintenance costs. Thus, it is more efficient in long terms. The main components of hydropower, such as reservoir, turbine, and generator. Nowadays, domestic or in-pipe hydro system also getting attention of researchers because of their low cost installation, long maintenance, and ease of access.
Next, I'll be presenting about hydropower, focusing on its definition and classifications. First, what exactly is hydropower? Hydropower or hydroelectric power is the generation of electricity using the movement of water. When water flows from a river or a reservoir, it has potential and kinetic energy. This energy is converted into electrical energy through turbines and generators because water is naturally replenished through the water cycle. Hydropower is considered clean, renewable, and environmentally friendly compared to fossil fuels. Now let's look at the first type of classification, which is based on the type of hydropower facility. There are three main types, which is first, run-of-river systems. These rely on the natural flow of the river with little or no storage. It's environmentally low impact, but the power output can vary depending on season. Secondly, reservoir or storage systems. These involve dams that store large amount of water. Water can be released when electricity is needed, making these systems more stable and reliable. And thirdly, pumped storage systems. This type acts like a huge energy storage system. Water is pumped up to an upper reservoir during low demand periods and released to generate electricity during peak demand. These three facility types represent the main structures used in hydropower plants.
Thank you. Now I will continue with two more hydropower classification. The second classification is based on size or installed capacity. This refers to how much power the plant can produce. For large hydropower, it can produce above 30 megawatts. For small hydropower, the range is between 1 to 30 megawatts. For mini hydropower, the range is around 100 kilowatts to 1 megawatts, and for micro hydropower, it's below 100 kilowatt. Smaller systems are usually installed in rural or remote areas where a large dam is unnecessary or too costly. Next, let's go to the next classification that based on water flow or operating scheme. There are three common categories. The first one is impoundment system. These use them to store water and control the flow for electricity generation. The second one is diversion or channel systems. These redirect part of a river through a canal or penstock, usually with minimal damming. And the third one is pump storage system. As mentioned earlier, this system store water at higher elevations and release it to meet high electricity demand. Understanding these classifications will help us to recognize how hydropower plants work with different environment and energy needs. Thank you.
Assalamualaikum and hello everyone. Today I will explain the mechanical and environmental properties and also the design of hydropower. Mechanically, hydropower uses turbine and generator. The turbine turns with water flow and the generator converts the motion into electricity. This part must be strong and efficient to handle high pressure and continuous use. Environmentally, hydropower is a clean and renewable. producing no air pollution. However, large dams can affect river flow and aquatic life, so modern design include a fish passage and environmental control. In terms of design, hydropower plant has a dam or reservoir, an intake and stock to direct water, a turbine, a generator, and a spillway to release extra water safely. In a short, hydropower combines strong mechanical system with eco-friendly design to generate sustainable energy.
Now let's talk about how hydropower is characterized, which is the key factor that determines its performance and sustainability. Hydropower converts the potential energy of water into electricity. Its theoretical power is given by P equals to rho times G times Q times H times theta, where rho is the density of water, G is gravity, Q is a flow rate, H is the net heat, and theta is overall efficiency. To characterize a site, engineers measure flow using river gauge or models, determine height from elevation data, and evaluate efficiency through turbine tests. These parameters define how much energy can actually be produced. Next, the key tools and indicators. A major tool is the flow duration curve, showing how often a given flow occurs. Combining it with efficiency curves help estimate annual energy and choose the right turbine type, which is Pelton, Francis, or Kaplan, depending on the site head and flow. Performance is summarized using indicators like capacity factor, which compares actual output with the plant's maximum potential. Move on to the environmental and monitoring aspects. Modern characterization also examines environmental and social impact, such as changes to the sediment transport or fish migration. Using hydrological and ecological monitoring, the accurate data on flow head and ecosystem response ensures hydropower remains efficient and sustainable. So, all in all, characterization is the foundation of reliable and responsible hydropower development.
Hydroelectric power. What is the impact towards the environment? As we all know, hydroelectric power is one of the most powerful resources and also one of the oldest power sources of renewable energy on Earth. Using nothing but only the flow of water, it can generate a massive amount of electricity. But what does it really mean for the environment? So let's start with the good part. Hydroelectricity is a clean and it's no burning fuel, no smoke, and a very little carbon emission. That means it helps fight climate change and reduce air pollution. It's also renewable. As long as rivers flow and the rain falls, we can keep generating power. And with an efficiency rate of nearly 90%, it's one of the most efficient energy systems ever built. Plus, hydroelectric dams don't just make electricity, they help control flood, store water, and support irrigation for farming. But there's another side to the story. Building a dam changes everything around it. Rivers stop flowing, fish can't migrate upstream, the entire ecosystem gets disrupted. Forests and wildlife habitats can disappear under huge reservoirs, forcing both animals and people to move. And here's something surprising. Some reservoirs actually produce methane gas, a greenhouse gas even stronger than carbon dioxide, because plants and organic matter decompose underwater. The downstream, the water quality can drop, the sediments that once nourished the land get trapped behind the dam. Even the land itself isn't always stable. The large dams can sometimes trigger landslide or small earthquakes. So, is hydroelectric power good or bad for the environment? The truth is, it's both. It's a cleaner alternative to fossil fuels, but it comes with serious ecological costs that can't be ignored. The challenge is for us now to find balance, to keep the lights turning on without turning the planet